So today we'll be doing logarithms, which are a logarithm is an inverse function of an index. So if you watch the last video, you would know that in index form, this is known as the base, this is the power, this is the number. We can rewrite this in logarithm form as log base a of z is equal to x. So the base goes here, the power is the solution, and z becomes the number we're logging. Now, just like indices, logarithms has laws to guide you in using it. First one, log base a of a is equal to 1. As you would know, a to the 1 power would give you back a. Log base a of 1 is equal to 0 because a to the 0 power gives you 1, and the 0 power always gives you 1. If log base a of x is equal to log base a of y, therefore x is equal to y. This symbol, 3 dots, means therefore in mathematics. Next one, log base a of xy is equal to log base a of y plus log base a of x. This is known as the addition or multiplication rule, some people call it. And very simple, log base a of x divided by y is equal to log base a of x minus log base a of y. So when you're logging numbers that are dividing, you can just log the numerator and subtract the log of the denominator. In log, whenever you see log of x, or you see LGX, it means log to the base 10. So base 10 is like a standard log. So if you just see log or you see LGX, it means the base is supposed to be 10. If you see ln, it's called a natural log, and it means a log to a base of ex. E is a mathematical constant known as Euler's number, and it's 2.718. It's normally used in business calculations for compound interest. Here's another law that is very important, and it normally poses a challenge, so pay very close attention. Change of base log. Now, if you have log to the base b of a, you can change the base k to a base x, and it becomes log to the base xa over log to the base xb. And you can also write this as 1 over log to the base a of b. So if you put this as the base and this as the number, you can just invert it, make it 1 over log a base b. Log b base a. Here we go. Can go ahead and try some problems. First one, expressing log form. So first thing, you identify the base, identify the power. So we can write this as log base 10. Of course, you know the power is what is equal to, so you put 2, and then you have 100. So log to the base 10 of 100 is 2, or 10 squared equals 100. Again, identify the base with this x, so log to the base x 0 of 1. Of course, you know anything with the 0 power gives you 1. Log base 4 16. Log base 5 125. See, very simple. You can just look over these. Now find the value of these ones. Now for these ones, you need to change from log form back to index form in order to solve it. So first you identify the base, the power, the solution, that equals to 4. Now the best way to go about this is to try and get them to the same powers, either the same powers or the same base. And we can do this by rewriting 4 as 2 squared. So we can say x squared is equal to 2 squared, which would make x equal 2. Again, x to the 4 equal to 625, and you can rewrite this as x to the 4 is equal to 5 to the 4. It's important to know your indices tables for certain numbers like 2, 3, 4, and 5. Those numbers are very important. It's very important that you know your table for them, indices table. For this, we can say that x is equal to 5. Two to the x is equal to 6 to 4. Now for this one, you want to get them to the same base. So you try to rewrite it to 4 as a base of 2. By doing that, we can say 2 to the x is equal to 2 to the 6. Therefore, x is equal to 6. Now let's go ahead and try solving an equation. Now when you get an equation like this, and you can put them to this, you can put them to the same base, or you could have gone ahead and log both sides. Since 4 can be reduced to a base of 2, best to go ahead and put them to the same base. So you can say 2 to the x plus 2 equal to 2 squared to the x minus 3. According to the law of indices that we learned last time, this should be 2 to the x plus 2 equal to 2 to the 2 times x minus 3, and so it should be 2 to the x plus 2 equal to 2 to the 2x minus 6. Therefore, we can say x plus 2 is equal to 2x minus 6. Then we could just solve for x. Now, the way you could solve this using logarithms, let's rewrite this here. So to 4 to the x minus 3, you could log both sides. Just use a standard log of this, then log both sides and say log 2 x plus 2 equal to 4 equal to log 4 to the x minus 3. And according to the power rule of logarithms, this should be the same as x plus 2 log 2. And this should be the same as x minus 3 log 4. And then we could just group like terms, and we can say log 2 over log 4 equal to x minus 3 over x plus 2. You can punch this in your calculator for the log part. And that gives you a half is equal to minus 3 over x plus 2. And then you can bring this over to multiply and say, so you can make bring over and say x plus 2 over 2 equal to x minus 3. So bring the 2 over, and you can see that x plus 2 is equal to 2x minus 6, which if I recall was what we got last time. Then you can solve it algebraically by grouping like terms. So x minus 2x is equal to negative 6x minus 2. Therefore, negative x is equal to negative 8. X is equal to 8. You can go ahead and check it back. Maybe there was an arithmetic mistake in there somewhere. Always double check your work. Okay, alright, so now we're gonna do a change of base. We're gonna evaluate these by changing the base 10. So, following the law, this can change the base to 10. Say log base 10 of 4 or log base 10 of 3. Just put that on the calculator. And that gives us 1.26. Next one, log base 10 of 6 over log base 10 of 9, and we can punch that in. To give us 0.815. There we go. And that's logarithms.